Hello everyone, this is Kenneth Bruni from Tech, and welcome back to the channel. So in this series of videos, we are learning Python, and this is specifically SENG 207 Programming for Engineers, taught at the University of Ghana. So if you have been following this series of videos, you could see that we are building on the previous knowledge that we've gathered so far, and this has been structured in a form of what I would say like the chapters of a book. So currently we are on chapter 11 where we have Boolean operators. So I'll collapse this so that we can have time to actually read everything over here. So these are the notes, and I think these are very important. Now everything you see over here is a comment. So currently everything as I've highlighted over here is a comment, and over here too I'm using the triple quotes. Now I have, of course, if you downloaded the GitHub repo earlier on, these are changes, and as and when I get new information and I feel I need to explain certain things better, I do add up onto this. But then later on I'm going to update it, so maybe people who watch this later on are going to have the benefit of everything intact. So these logical operators, we normally would also refer to them as Boolean operators, and we are going to use the AND, the OR, and the NOT. And like I stated over here, they are also referred to as the Boolean operators. Now they are used to combine conditional statements, and that's not only that, the other functionalities we are going to look at. So basically I want us to draw inspiration from what we already know and kind of link things up together. Now the Boolean operators or the logical operators are nothing different from the logic gates we already know. So for the benefit of those who may not know, I just want to give you a sneak peek into what these logic gates are. Now in electronics, there's something we call logic gates, and those are more or less the fundamentals of electrical circuits. So here we have, assuming we have two inputs, if we apply the AND gate, so the input A and the input B, and if input A gives us a 0 and input B gives us a 0, and in terms of electrical signals, the 0 is going to be a low signal and the 1 is going to be a high signal. So if we have a 0 and 0 and we apply an AND gate to it, the resulting result we get is going to be a 0. Now the simple trick over here is, with the AND gate, both inputs needs to be high or needs to be 1 before we get a 1. Now in the case of our code implementation, the 0 will be used to represent a false and the 1 will be a true. So if we have, for instance, a false statement and a false statement, and we are using the AND logic gate, then that resulting statement will become a false statement. It only becomes true if both of them are explicitly true. Now let's see an example before we move on to the other gates. So what I'm going to do over here is, let's say I have x and x is equal to 10, and I have y is equal to 5, and finally I have z is equal to 10. Now based on the previous knowledge that we have, we were doing something like, and this was when we were trying to use the comparison operators. So for instance, if I'm to do x and I'll say is equal to y, clearly this is a false statement because x, which is 10, is not equal to y. So now when I run this, I do get a false over here. So what about x is greater than y? Indeed, x, which is 10, is greater than y, so we do get a true statement over here. Now this is where the AND comes in, and this is where we use to chain or combine these operators. So I can say AND, for instance, x is equal to y. Let me use z over here for the purpose of this argument. Now once again, let me just cut this exclusively. If we just do x greater than y, we get a true statement over here because indeed x, which is 10, is greater than y. Now if I bring this up and also exclusively try and check if x is equal to z, we clearly see this over here as both of them being 10. So definitely this is also a true statement. So now the question is, if we want to combine the two and check, remember this was giving us a true and this is also giving us a true. And it doesn't matter if we leave some white spaces just to make things very clear. This is giving us a true statement, and this is also giving us a true. And that's what we are representing as 1, 1 over here. So the resulting AND gate operation is going to be a 1, in which case it's going to be true. So now when I save this and run this, we get a true statement over here. Now let's experiment with the other options we have over here. Let me just bring this a little bit up so that we see the logic table as we try and work our way through. So let's say we have a false and a false, so 0, 0, and we are expecting to see a resulting false over here. So for instance, definitely x is not equal to y, and we can actually verify this. So if I'm to cut this, this is going to give us a false, in which case we are saying that this is a 0. So this is like the first input, which is giving us a 0. And the second input I would want to evaluate is, for instance, let's say y is greater than z. So y is greater than z. We can clearly see over here that 5 is not greater than z. So if we are to exclusively also check this out, we are expecting to see a false statement over here. Now if we combine both, remember both of them are false, so both of them are 0 over here. The resulting AND operation is going to yield a false or a 0. So now when we run this, we do get false over here, and you can check with the other ones. So for instance, this, let's maintain this because this is a false, and now let's make B a true statement over here. So for instance, we can say that y is less than z, which in this case is a true statement. But then when I run this, we do get a false over here, and we are getting a resulting false because we are using AND. The AND will only return true if everything we are trying to combine or trying to check is actually true. And we can use this for a number of operations. So this is looking good. Now let me comment this one out, and let me actually delete this and cut this and try and experiment with the OR gate. So let me paste my variables over here, and now let's look at the logic table for OR gate. So clearly we see that we have our inputs A and B, and this is the OR operation. Now the OR operation will return true if either of them, so it just has to be one of them has to be true. So clearly you could see that in the case of the first instance, both A and B were false, so definitely the OR operation is going to be a false statement. Now when we come to the second instance, we have A giving us false and B giving us true, and because just one of them is true, we do get a resulting true for the OR gate. Now in the case of the third instance, we have A being true and A being true and B being false, and because one of them at least is true, we do get a true at the resulting OR gate. And finally, when we come to the last instance, we have both of them being true, and as a result, we also get a true statement over here. So let's test with some examples, and let's try the first one where we have both of them being false. So for instance, if we are to check, let's say y is equal to x, this is definitely a false statement because y, which is 5, is not equal to x. If I'm to run this, we do get a false over here. And let's also do OR. So we type in OR over here. If you are to check, for instance, z is greater than x. Now z is definitely not greater than x, but then it is equal to x. So clearly, if I'm to exclusively check this over here, I'm also going to get a false. And now when I run this, I do get a false. So now the question is, what then happens if we combine both using the OR statement? So if you combine both using the OR statement, because both of them are false, definitely the resulting operation using the OR statement or the OR gate is going to give us a false result. Now if I'm to do something like is equal to over here, now this becomes true because indeed z is equal to x, and this is still remaining as false. Now, because we are using the OR gates and at least one of them is true, the resulting OR operation is going to give us a true. And this in particular is going to be a resemblance of what we have over here, because the first input is false and the second input is a true statement. So we are expecting to see a true statement over here. So now when I save this and run, we do get a true statement over here. Let's look at this instance where we have a true and a false. So definitely if we are comparing this, then Z is not less than X. I mean, they are the same. So this is a false statement over here. Now let's make this a true statement. And in order to make this a true statement, let's try and be very crafty with some of these things. So let's say we have X over here, and let me just use Z over here. So definitely we can combine these, okay? And sorry, we can combine these. So the question is X less than or equal to? Remember, this is a true statement because, and for the purpose of clarity, let me just cut this and run this. So this is a true statement, and this is what we are using to represent this. And now if I'm to bring this up exclusively, cut this one out, save this and run this, this is a false statement. So this is what we are using to represent this input. So now let's combine both using the OR gates, and the resulting output is supposed to be a true statement. So now when I run this, this is true. Now the whole point is, for the OR gates, just only one of them has to be true in order to get a true statement. Good. Now let me also comment these ones out and see what we have. So clearly we have covered the AND gate and the OR gate, and there's also the NOT gate. Now this is how the NOT gate looks like. Now the NOT gate will basically negate the resulting inputs. So for instance, if A is 0 and we NOT A, it is going to give us a 1. So in essence, if A is false and we negate it or we NOT it, then we are going to get a true. In that same way, if it is a true and we negate or we NOT it, we are going to get a false. And the same principle applies to things over here. So let me just once again copy what I have over here. So I'll do a Control-C and try and paste it in here, and I'll uncomment it so that we can actually have access to these variables. So now let's see how we NOT some of these things, and it's as simple. We just have to use the NOT operator over here. So for instance, if I'm to do, let's say X is greater than Y, this is a true statement. So when I run this, indeed we have a true statement over here. But then if I'm to negate this by wrapping it up in a NOT keyword over here, then it is now going to change this into a false statement, and that's exactly what you see over here. Now you can try with different examples, but the whole point is, why are we doing this in the first place? Now this is very important. Let's say you are writing an application that is going to check, let's say, for a number of criteria to be met before something happens. So let me give you a typical example. So let's say you are writing an application to check a number of things. Let's say a student, okay, and want to check if the student is one, maybe Ghanaian, and you also want to check if the student is a male, and you also want to check if the student is an undergrad student. So if you really want to make sure that all these criteria is met before that person qualifies for a scholarship, then that's going to be an AND operation, and that's what you can use to check. Or if in case you want to check if the student is a female, the student is a non-residential student, and the student is maybe an athlete, then you can use those ones to also check. Then the OR gates is definitely going to apply using that same principle. So that's going to be the Boolean operators. Now there's what we also have over here as the identity operators. And in this particular session, I just wanted to combine things together so that you don't have to go about these operators over and over again. So we are combining this with identity operators. Now these identity operators, we have the is and not, is not. Now we can use this to check both the value and data type of an object. Now remember, in our previous encounter when we were dealing with the comparison operators, we had Or I showed an example like this where we had 10. Then for instance, let's say y is equal to a 10.0. Now if I'm to print out something like this and I'll say x is equal to y, in which case I want to compare the value in x and y. In the case of x, it is 10, and in the case of y, it is 10.0. Now when I run this, we do get a true statement over here. That's what we have printed out over here. Now basically, based on our understanding of the previous chapters, we know that x is being stored over here as an int and y is a float. So over here, when we just do this, we're only checking the value and not necessarily data type. But then we can use the identity operator to also check for the data type. And this is what I mean. So now if I'm to do x is y, this is checking for both data and data type. So now when I run this, we do get a false statement over here. Now if I change this back to, let's say, 10 and run this, we do get a true statement over here. So clearly we can see that it is checking for both data and data types. In that same way, if we are to make this, for instance, a string and run this, we do get a false statement over here, because when it was checking for data, it realized that x is an int and y is a string in terms of data type. So we just have to be mindful of this. And this actually answers some of the questions that were being posed in class. Now the is not will basically negate everything we have over here. So I can say x is not y, and indeed x is not y in terms of data type. So now when I run this, we do get a true statement over here. If we have this as 10.0, in terms of data type, x is not y. So now when I run this, indeed x is not y, so it is a true statement over here. But then if both of them are the same and I'm trying to say x is not y, clearly this is going to tell me that this is a false statement, and that's what we see over here. So this is looking good. Now let's comment this up over here. And finally, let's look at what we have over here as membership operators. I think at this point I can just clear these ones over here. So these membership operators are used to check if a sequence is present in an object variable. And this is very interesting. So now let's look at a variable like what we've been using all along. So we have school and we have University of Ghana in here. Now we are going to use the membership operator, and we use the in and the not in as the membership operator. So now this is what I want to do. I can print, and I'm going to check if a series of strings like Ghana in, and I'll say school. So this looks like a very simple English statement. So I want to check, is Ghana in the variable school? Okay. So if your guess is as good as mine, when I run this, we do get a true statement being printed out over here, because indeed we see the sequence Ghana inside of school. Now remember, Python is case sensitive. So if I'm to do a small letter G Ghana and run this, we do get a false statement being printed out over here, because based on the sequence of characters that we have over here, we don't have Ghana small letter G over here. Now let's say we have, or we are trying to check something like uni. Now when I save this and run this, we do get a true statement over here, because at least we have uni being shown or showing up over here. Now let's also check for a word like Nigeria, and clearly we don't have Nigeria over here, so we see a false statement over here. So now let's look at the not in, and I can say I want to check if Nigeria is not in school. Basically, this is how grammatically we may be reading this. So I want to print and check for me if Nigeria is not in school, as in the string I have over here. Now when I run this, we do get a true over here, because indeed Nigeria is not in school. And if we are to first of all check with the in membership operator, clearly tells us that this is a false statement. So as the name suggests, it is actually checking if what we are searching is actually a member of that sequence or string that we have in there. And we can use this to check for other things, for instance in lists and other data collections we are going to look at later on. Good. So now this is going to be the end of this video. Now if you have any question, kindly put it out in the comment section, and if anything is too difficult for you, just try and Google search, try and do your own personal reading, and I think definitely you find solutions online. Now you find value in this series of videos I'm putting out here, now kindly support me by subscribing to this channel, and don't forget to hit on the notification button so that anytime I release a video, you'll be duly notified. Also share this video with friends and family who find this content very useful. At Tech, we say learn programming, you can do it. Bye bye, and catch you in the next video.